In this direction this force is minus, so sigma r r3 into d theta agree? Now this force again, this is the shearing force in this direction, we are taking the equilibrium in this direction. So tau r d theta 2 and the length of this is, we are taking the small element, this length is dr, small element dr. In the plane coordinates we take the dx, in this case it is dr, so multiply by the length dr minus tau r theta, one force is, this is opposite, theta 4 multiply by the distance dr, length. Now d theta is on the inclined plane, so its component will take its component, one component in this direction, another in this direction. So in this direction it is sin theta, so d theta 2 into length dr is the force, total force, d theta 2 into dr is the total force, and its component is in this direction is sin theta, sin d theta upon 2, sin d theta upon 2. Similarly, for this theta 4 into dr to sin d theta upon 2. As the angle d theta is very small, so d theta upon 2 is also small. So for a very small angle, sin theta is very small. Sin theta is theta. Yes. So here in the next step you write down the same. You write down the next step and eliminate the sin, only d theta upon 2. sigma r we can write here like this, d theta minus sigma r 3 d theta minus d theta upon 2. So 1 upon 2 we can take common, theta 2 d theta 4 plus tau r theta 2 minus tau r theta 4 if there is a external force R, then the total area of the ABCD is R d theta into dr. Center R d theta into dr is the area of this. So for the external force R, this is equal to 0. दिख रहा है आपको सर?
Yes, sir. Yes.
Now divide the equation by dr into d theta. Divide the full equation by dr d theta.
Yes, sir.
So here you will get dr r 1 minus dr r 3 divided by dr, because d theta will get cancelled. Here you will get d theta 2 into dr, लेंथ मैं भूल गया था मल्टीप्लाई करना, d theta 2 into length dr. ये dr था ना इधर, r into small r. यहाँ पे ये दोनों था dr d थीटा, है ना, दिस इज द d theta 2 minus this dr and d theta both थे, so both the cancel, so only 1 upon 2 d theta 2 plus d theta 4. आया क्या आपको सर समझ में थोड़ा?
आपको कुछ मेरा आपका थोड़ा सा
डी आर डी थीटा से डिवाइड किया तो यहाँ डी आर बच गया, यहाँ डी आर डी थीटा दोनों था, दोनों कैंसिल हो गया, 1/2 माइनस कॉमन लिया तो दिस बचा, और यहाँ पे डी आर था तो डी थीटा बचा, और यहाँ दोनों थे फिर से तो आर इंटू आर बचा. If the dimension of the element taken, if the dimension of the element taken smaller and smaller, to the limit 0, if the dimension of the element taken smaller and smaller to the limit 0, so first term become del sigma r into r upon del r. The second is the average of this is theta. The third is again we divide by the r, small r. So these r get cancel, theta upon r, 1 upon r, tau r theta upon del theta. नेक्स्ट स्टेप में करेंगे या तो आर से डिवाइड नेक्स्ट स्टेप. You please correct, sir. We'll divide by dr next time, in the next step. You write down this is the correct. You make the correction. Now d by dr of multiplication of the 2 multiplication of the two. So, it is first term and differentiation of the second. So, first term is sigma r. First term is sigma r and d by dr of r is 1.
Yes, sir.
So, it is 1 plus second time, yes, into del r, del sigma r by del r, like this. This is the differentiation of this. Now, other will remain the same. So, in next step you write this and the same. You write down the next step, this and the remaining is the same.
Yes, sir.
Now you divide by the r. Now you divide the whole equation with small r. So, here as you divide by r, you will get del sigma r upon del r. Okay.
Yes, sir.
Here you will get sigma r upon r and d theta upon r. You can write this in the word term. So, this is sigma r minus sigma theta upon r. I am writing these two together. Here you will divide by r, so you are getting tau r theta upon del theta. And here you will divide by r, so you will get r is equal to 0. This is equation number 37. This is equation number 37. On the page 66 of your book, Timoshenko. Should I remove?
Yes, sir.
Now you can write the equation of equilibrium. The equation of equilibrium in the tangential direction. The equation of equilibrium in the tangential direction means we are deriving in this direction. Now, in this direction we can also do the same thing and we can derive the equation, and that will be 1 upon r del sigma theta upon del theta plus del tau r theta upon del r plus 2 tau r theta upon r. Instead of r, it is s is equal to 0. Yes, where s is the component of body forces, where s is the component of body forces per unit volume in the tangential direction. In the tangential direction. These equations are same as we derive in equation 18 previously, del sigma x upon del x plus del tau xy upon del y plus capital X is equal to 0, del sigma y upon del y del tau xy upon del y del x plus y is equal to 0. Equation 14 in our previous notes. When we solve लिख रहे हैं क्या सर आप?
हाँ सर.
When we solve two dimensional problems, when we solve, this is equation 18 not 14,
हाँ सर.
18.
हाँ.
When we solve two dimensional problem by means of polar coordinates, when the body forces are 0, when we solve the two dimensional problem by means of polar coordinates, when the body forces are 0, they are satisfied. When we solve two dimensional when we solve two dimensional problems by means of polar coordinates, when the body forces are 0, when the body forces are 0, they are satisfied by putting sigma r is equal to 1 upon r del phi upon del r 1 upon r square del square phi upon del theta square, sigma theta is equal to del square phi upon del r square, tau r theta is equal to 1 upon r square del phi upon del r del theta माइनस 1 अपॉन आर डेल स्क्वायर 5 अपॉन आर स्क्वायर डेल 5 अपॉन डेल थीटा. You can also write this as del upon del r upon r del 5 upon del theta. Equation 38. I think it is enough for today.
हाँ सर बहुत हो गया.
आपको बोर किया हमने.
मैं भी बोल नहीं थे.
क्या करें, सब्जेक्ट ऐसा ही है ये, थोड़ा सा बेकार.
इसलिए मैथमेटिक्स नहीं लगाता.
हाँ. और वो भी अगर आप सामने होते तो आपको और अच्छा समझ में आता, पर अब क्या कर सकते हैं. हाँ नहीं नहीं सही बात है. आप बाकी लोगों को तो आप मुश्किल है. हाँ सही बात है. आपको मैं भेजता हूँ सर ये बाकी के भी लेक्चर, तो आप उसको हाँ सही सही बात है. यस सर, यस सर. यूनिट 1 आपके पास है ना अभी? यूनिट 1 है, कौन सा है? मैंने भेजा हुआ होगा यूनिट 1 शायद. देखेंगे पर्सन, मैं देखूंगा आपके इस पे क्या भेजा है. बाकी का भी भेजता हूँ मैं, है ना सर. ओके चलिए, हैव ए गुड डे. कौन है इधर? बंद कर दीजिए अभी.